Today we're diving into a paper that explores a novel approach to improving the instruction following capabilities of large language models, LLMs. The paper, Reflection Tuning Data Recycling, Improves LLM Instruction Tuning, proposes a method called reflection tuning to enhance the quality of instruction tuning datasets. Let's discuss the challenges that this paper addresses. What are the limitations of traditional instruction tuning methods?
Traditional instruction tuning methods often struggle with the quality of training data. If the training data contains inconsistencies or low-quality instructions and responses, it can lead to inconsistent or even misleading outputs from the LLM. This is because the model learns from the data it's trained on, and if the data is flawed, the model's performance will be negatively impacted.
So the paper proposes a solution to this problem. Can you explain the core concept of reflection tuning?
Reflection tuning is a method that uses an Oracle LLM, like ChatGPT, to introspectively assess and improve the existing instruction tuning dataset. The Oracle LLM acts as a judge, evaluating the quality of the instructions and responses in the dataset and suggesting improvements. This process of data refinement is called recycling.
How does the Oracle LLM actually recycle the data? Can you elaborate on the process?
The recycling process involves two main phases: instruction reflection and response reflection. In the instruction reflection phase, the Oracle LLM is given an instruction response pair from the original dataset. It then reflects on the instruction based on specific criteria, such as the complexity of the topic, the level of detail required, and the ambiguity of the instruction. Based on this reflection, the Oracle LLM generates a new, improved instruction.
So the Oracle LLM is essentially rewriting the instructions to make them clearer and more effective.
Exactly. The Oracle LLM aims to improve the clarity, specificity, and overall quality of the instructions. The second phase, response reflection, focuses on the response itself. The Oracle LLM evaluates the response based on criteria like helpfulness, relevance, accuracy, and level of detail. It then generates a revised response that addresses any shortcomings identified in the original response.
This sounds like a very thorough process. What are the key benefits of using reflection tuning?
Reflection tuning offers several advantages. First, it allows for the autonomous improvement of existing datasets without requiring additional model training. This is a significant advantage, as training LLMs can be computationally expensive and time-consuming. Second, the method is universally adaptable to various instruction response pair architectures. It can be applied to any dataset that contains instructions and responses.
Those are interesting. Can you provide some examples of how reflection tuning has been applied in practice?
The paper evaluates the effectiveness of reflection tuning on two widely used instruction tuning datasets, Alpaca and Wizard LM. The results show that LLMs trained with recycled data outperform those trained with the original datasets in various benchmarks. For example, the recycled Wizard LM-7B model achieved the highest win rate among other open-source 7B models on the Alpaca Evil leaderboard.
That's impressive. What are the specific metrics used to evaluate the performance of the models trained with reflection tuning?
The paper uses several metrics to evaluate the performance of the models. One metric is the win rate, which is determined by comparing the responses generated by the models to benchmark responses from a reference model, such as GPT-4. Another metric is the average score on the Hugging Face Open LLM leaderboard, which assesses the model's performance on various tasks, including question answering, common sense reasoning, and factual language understanding.
So the results indicate that reflection tuning significantly improves the quality of the training data, leading to better performing LLMs. What are the potential implications of this research for the future of LLM development?
This research has significant implications for the future of LLM development. By improving the quality of training data, reflection tuning can help to create more reliable, consistent, and high-performing LLMs. This is crucial for ensuring that LLMs can be effectively used in various applications, such as content generation, question answering, and code generation.
It seems like Reflection tuning is a promising approach to address the challenges of data quality in instruction tuning. Are there any limitations or potential drawbacks to this method?
While reflection tuning shows promising results, it's important to acknowledge some potential limitations. One limitation is the reliance on an oracle LLM, which itself may have biases or limitations. The quality of the recycled data is ultimately dependent on the capabilities of the oracle LLM. Additionally, the process of reflection tuning can be computationally expensive, especially for large data sets.
That's a good point. The reliance on an oracle LLM raises questions about the potential for bias and limitations. How can we mitigate these risks?
It's crucial to carefully select the oracle LLM and to consider its potential biases. Researchers can also explore methods for diversifying the oracle LLMs used in the reflection tuning process. This can help to reduce the impact of any single LLM's biases. Furthermore, ongoing research into improving the robustness and reliability of LLMs will be essential for ensuring the effectiveness of reflection tuning.
So while reflection tuning is a promising approach, it's not a perfect solution. It's important to be aware of its limitations and to continue exploring ways to improve its effectiveness. Can you discuss any future directions for research in this area?
Future research could focus on developing more sophisticated criteria for reflection tuning, exploring alternative methods for data recycling, and investigating the use of multiple oracle LLMs to enhance the diversity and robustness of the process. Additionally, researchers could explore the application of reflection tuning to other areas of LLM development, such as fine-tuning for specific tasks or domains.
This is a fascinating area of research with the potential to significantly impact the development of LLMs. Can you summarize the key contributions of this paper?
The paper introduces a novel method called reflection tuning for improving the quality of instruction tuning datasets. It leverages the self-improvement capabilities of LLMs to autonomously recycle and enhance the data. The paper demonstrates the effectiveness of reflection tuning through extensive experiments on widely used benchmarks, showing that models trained with recycled data outperform those trained with traditional datasets.
Thank you for sharing your insights on this important research. It's clear that reflection tuning is a promising approach for addressing the challenges of data quality in instruction tuning, and it will be interesting to see how this research evolves in the future.